Hello, mineralogist and geochemist, and this is my second tiny lecture about geology, which I began to provide mainly you may find in the and as I told in my previous an exact line between mineralogy and other sciences, and as well between minerals and synthetic compounds. And in this second video, I would like to talk a little bit more about this kind of border, especially that I just recently had another one of many discussions about what is a mineral or what is a synthetic mineral. It was quite, I must say, a difficult discussion, but it brought me this idea that I now have some examples of situations where, as you will likely see in a minute, some situations are quite easy to choose, to say if, okay, this is a mineral or not, while in other situations it's quite not that easy. First, such a situation is quite well common and well known. Okay, if you want to drink, you go to your fridge, and you have ice cubes. And these ice cubes, if you go to semantics, are not a mineral. However, what are they being made of? They're made of a substance known as ice. However, this is a kind of mental shortage expression, which is quite unlucky, may I say, because what you have formed, what you have made in your fridge is not a mineral. It's a synthetic form of crystallized water. It is very important to say crystallized. It must be crystalline. However, if you go outside on winter and you see icicles, these icicles formed naturally without your intention and are called ice too. However, what makes these icicles is a mineral. The situation is, and the truth is that the way the atoms are being placed in these crystals, both in the case of the mineral known as ice or synthetic counterpart, which is unfortunately also called ice, in your fridge are more or less exactly the same. However, this term ice is much more broad, which makes things even more difficult, because we are used to live on the Earth's surface, and this place is well known for us, and we barely know other conditions unless we go hiking, for instance, high to the mountains. But if we visit places like the moon Titan or Pluto or other objects like this, then we likely could find some natural water ice. However, there are much more other types of ices, and for instance, methane ice or nitrogen ice. Some of these ices are also known in chemistry as clathrates, but this is not good time to discuss this. So this is a very specific situation in terms of semantics, where kind of a mental shortage term ice is being used for different substances. However, in terms of their internal structure, they're exactly the same, more or less. Other situation is what I can show you actually. At the bottom of this cup, the still remnant of some tiny blue crystals, and these are crystals, of course, which are being made by copper sulfate pentahydrate. You may buy such crystals in mineral markets, also in the internet, for instance on eBay and some mineral shops, and often they will be called halcanthite, which is of course wrong, because in this case these crystals were intentionally made crystallized from a solution by human, for instance, to bring you large crystals of the substance. Technically, we cannot call the crystals I showed you halcanthite, because halcanthite is a mineral counterpart of the synthetic compound, and I will show you how does it look a natural counterpart, a mineral. a true halcantite, a mineral that was formed also from solutions, however, totally natural in the nature, in a copper deposit which undergoes oxidation weathering. So there's a difference. The substances in terms of atoms that they're being made of, and the way the atoms are being set in the internal structure are exactly the same, but the processes, the intentions of these processes vary, are different. So we have a synthetic compound versus a mineral. Here I have another example. This is a shampoo, and it's in Polish, but it says sea minerals. Of course, it's not true, and it's quite a common situation, especially on such labels. At the moment of extraction of these salts, and salt is like ice, salt is another term of a kind of mental shortage. Because there are different types of salts. There are plenty of salts, both in mineralogy and in chemistry. In this case, we are talking mainly about a mineral known as halite. This is a natural counterpart of a synthetic compound known as sodium chloride. As soon as it exists in the nature, and even at the time of its mining, it's of course still a mineral. However, you will not find any crystals in this shampoo. The halite is being intentionally dissolved to constitute the composition of the shampoo. As such, it is not a mineral anymore, and also you probably remember from my first video that minerals must be crystals. When they go into solution, they're being dissolved, and they begin to be mineral substances. Mineral substance is not equal to mineral. It's different. Okay, so we have these three situations, and it's quite easy to distinguish between a mineral and a synthetic compound. But one situation which was discussed recently in a forum on Facebook is of a little bit different and much more difficult type. You probably know that, especially in some arid regions of the world, there are places close to the ocean, at the seaside, where there being some kind of holes are being dug out, and either water from ocean or water that is contained in groundwaters goes into these pits, and is undergoing outgassing. The water is being outgassed. And the remainder is crystals of various salts, mainly the halite, this mineral which I told you about just before. However, from a very philosophical science philosophy point of view, there was a human intention to crystallize this salt. So from the process side, the crystallization is natural, so we get a mineral. However, from the intention side and from the definition side, more or less, it's not that obvious. And this is a very good moment to tell you about, at least to me, a very, very, very good writer, which was in the beginning of his career a physician and mathematician a little bit, but then he switched to parapsychology. Name is Robert Anton Wilson, and in his books, he, for instance, proposes a kind of play to displace the word "is" by sentences, terms, phrases like "it seems to be" or "it seems to be like." Basically, what he says is that science is barely 0-1 situation. Situations in the science, especially in sciences like chemistry and mineralogy, are rarely 0-1 situations, like it is or it isn't. A very good expression for the purposes of this video, I think, is by this model, by this kind of model, this crystal seems to be natural or seems to be a mineral or not. I must say that before throwing out this kind of thinking from my head, this kind saying, okay, this must be perfect. this model I prepare, this description of this crystal must be perfect. I must write about it as precisely as possible. Of course, I still try to do so when I write scientific papers about minerals. However, now in my head is this Robert Duncan Wilson saying, "Are you sure it is that possible? It is anyhow possible to make this description 100% sure? Usually it isn't." And this allowed me actually to send papers and to publish papers, because before I wasn't able, because I always wanted to bring the information to 100% certainty, which is barely possible, or rather impossible. Of course, there are situations where, and I think I have shown you such situations in the beginning of this video, where a crystal is a mineral, dot. However, most situations are not that certain. We also know such a situation for mineral markets, where people bring some minerals they bought to us, and they ask, okay, what is it? And usually it is impossible to say for sure, because especially in a macroscopic determination, a macroscopic term, minerals, even like calcite, are very similar to plenty of other minerals. At the time of this video recording, circa about 5,700 species of minerals exist, and believe me or not, there will be more. I will talk you about this. I will talk about this and discuss it in some of the next videos. That's starting from at least 10 or even 15 last years. Each year brings about, or between 110, 120 new mineral species. This is of course nothing if you compare it to insects, for instance. But still, there's a plenty of minerals, and believe me, most of them macroscopically look identically to other minerals. So it is usually impossible to say for sure what kind of mineral it is. You need analysis. Sometimes you need at least two techniques to be engaged for such analysis to say, okay, this is not calcite, this is a mineral from calcite group, but this is similar to calcite. Sometimes even three techniques are not enough to say with a 100% certainty what kind of a mineral it is, what's the name of the mineral. And to finish this, this will be a little bit maybe rude what I say. However, just recently I've seen such a term which says, if you do not grasp science, then this is not an argument against science. But we can also say that if you're not grasping science, you can always ask. And with this sentence, I would like to finish this video. I invite you to contact me if you want, if you need to ask, for instance, and feel invited and feel welcome to my next videos. Cheers.